So very good morning to Dr. Dean. So today I'm going to do about liquid characteristics and dimension analysis. My name is Rubaraj Yadavan. My metric number is 198240. So the liquid characteristics. What does liquid characteristic means? Liquid characteristic means a liquid is nearly incompressible fluid that conforms to the shape of its container but remains a nearly constant volume independent of pressure. And a liquid also have a defined volume, and a liquid is made up of tiny vibrating particles of matter such as atoms held together by intermolecular bonds. Most liquid resist in compression, although others can be compressed. Unlike gas, liquid does not disperse to fill every space of a container and maintains a fairly constant density. A distinctive property of the liquid state is surface tension, leading to wetting phenomena. So density. Density is one of liquid characteristic. What is density? Density is mass per volume. So the unit is be kg per meter cube generally. And then a density of a standard liquid will be 1000 kilogram per meter cube. Viscosity. What does viscosity mean? Viscosity refers to a liquid resistance to flow. In most cases, the viscosity of a liquid decreases as the temperature of the liquid is increased. Increasing the temperature will cause the molecular kinetic energy to increase. Therefore, it will break down the intermolecular forces between the liquid. Since viscosity is dependent on the attractive force, thus the viscosity will decrease when the kinetic energy increased. Then we go for temperature. What is temperature? Temperature is a property to determine the degree of hotness and coldness or the level of heat intensity of a liquid. So normally we use three temperature scales to measure temperature. So first will be Celsius, Fahrenheit, and Kelvin. Kelvin scale is widely used in engineering. This is because this scale is independent of properties of a substance. Pressure. Liquid will distribute pressure evenly. This concept is known as Pascal's law. It's crucial for equipment such as hydraulic systems, hydraulic brakes. The vaporization increases the temperature. It can be measured by vapor pressure, the amount of pressure exerted by the evaporated gas above the liquid surface. Vapor pressure increases with the temperature. Once it reaches the pressure of the surrounding atmosphere, the liquid will boil. Vapor pressure also depends on the intensity of intermolecular forces in the liquid. Then we go for the specific volume. Specific volume of a substance is the ratio between the volume and its mass, and it's the reciprocal of the density. And specific volume is also one of the intrinsic property of matter. So this is the specific volume formula. V equals to, we note it as small v, volume over meter. Volume over mass, it will be meter cube per kg. Specific weight. Specific weight will be denoted with this symbol of a liquid is defined as specific weight equals to density times the gravitational acceleration. So the SI unit for specific weight is Newton per meter cube, while the English unit will be IBM per feet cube. Specific gravity is simply the ratio of specific weight of a given liquid to the specific weight of water at 4 degrees Celsius, which is 9.81 kilonewton per meter cube or 62.4 lb per feet cube. So specific gravity is equals to specific weight of the liquid over the specific weight of water at 4 degrees Celsius. Dimensional analysis. What is dimensional analysis? It's a mathematical technique used to predict physical parameters that influence the flow in fluid mechanics. So the analysis involves fundamental units such as MLT, M for mass, L for length, and T for time. It is helpful for experimental works because it provides a guide to factors that significantly affect the studied phenomena. So then there are two methods we use for dimension analysis. First one will be Rayleigh method. An elementary method for finding a functional relationship with respect to a parameter in interest is the Rayleigh method. It will be illustrated with an example using MLD system. So this is the example which we got, and I also will give an example on that later. Buckingham's pi theorem is the second method. So the dimensions in the previous are analysis using Ray's method. Alternatively, the relationship between the variables can be obtained through a method called Buckingham's pi theorem. So Buckingham's pi theorem states that if there are n variables in a problem and these variables contains m primary dimensions, for example MLT, the equation relating all the variables will have n m dimensional group. Buckingham referred to these groups as pi groups. The final equation obtained is in the form of pi1 equals to function pi2 pi3 till pi n minus m. The pi groups must be independent of each other and no one group should be formed by multiplying together powers of other groups. This method offers the advantage of being more simple than the method of solving simultaneous equation for obtaining the values of the indices, the exponent values of the variables. In this method of solving the equation, there are two conditions. Each of the fundamental dimensions must appear in at least one of the m variables. It must not be possible to form a dimensionless group from one of the variables within a recurring set. A recurring set is a group of variables forming a dimensionless group. So first we're gonna look at the example 1, Buckingham's pi theorem. Consider a liquid in a cylindrical container in which both the container and the liquid are rotating as a rigid body, a solid body rotation. The elevation difference h between the center of liquid surface and the rim of the liquid surface is a function of angular velocity v, fluid density is noted as r, gravitational acceleration is noted as g, and radius is noted as r, a capital R. Use Buckingham's pi theorem to find the dimensionless relationship between parameters. Show all your work. So, step 1. There are 5 parameters in this problem, so n equals to 5. List of relevant parameters. H equals to function w rho g r, k equals to 5 bracket 1. The primary dimensions of each parameter are listed. H equals to h noted as L, noted as velocity, noted as t negative 1, rho noted as ml, negative 3, g noted as lt, negative 2, power of negative 2, r noted as L. That means it's used length, time, mass. So, step 3, as the first guess, j is set equal to 3. The number of primary dimensions represented in the problem m, l, and t. Reduction m equals to 3. If this value of j is correct, the expected number of pi's is n minus m. 5 minus 3 equals to 2. Step 4. We need to choose 3 repeating parameters since m3. Following the guidelines outlined in this chapter, we elect not to pick the viscosity. We choose repeating parameters w, rho, and r. So the dependent pi is generated. Pi1 is h rho power of a, h w power of a, p rho power of b, r power of c. Then we note with the MLT, just L, t negative 1 power of a, ml power of negative 3 times by power of b, L power of c. So m power of 0, t power of 0, L power of 0. So 0 equals to b, so b equals to 0. 0 equals to negative a, therefore a equals to 0. While 1 minus 3b plus c for L, so c equals to negative 1. The dependent pi is thus pi1 h over r. The second pi, the only independent pi in this problem, is generated pi2 g W power of A, rho power of B, R power of C. So you write back all the equation, you notate equals to 0, the power of equals to 0. Then for mass, P equals to 0. For time, you will get the A equals to -2. When you do simultaneous for L, you will get C equals to -1. So rho 2, pi 2 is G per W power of 2 R. Therefore, the relationship, step 3, the last step, we write the final functional relationship as pi s h over r equals to function g over w power of 2 r. Now we go for example 2, Rayleigh's method. The question is, find the expression of drag force on the smooth sphere of diameter denoted as d, velocity as v, in the fluid density as rho, dynamic viscosity as phi. So this is the analysis that I done for this question, which is, so we have a smooth sphere on a diameter d, and this sphere is thrown into a fluid with the velocity of v. The fluid has the density of rho and viscosity. As the sphere moves through the fluid, there will be a generation of drag force. Force will be against the motion of the sphere. So we need to understand drag force, and depends on d, v, rho, and v. So dependent variables is directly proportional to the independent variables. So the dependent variable goes to the function of the independent variables. Step 2, set up all the equations. So f, we put a constant, k as a constant. It's a dimensionless constant. And then d power of a, v power of b, rho power of c, and phi power of mu power of d. So set up tabular column. Then you set up all the tabular column, and then you write all the dimensions and the SI units as shown in this table. And then step 4, use dimension from step 3. Solve the unknown variables a, b, c, d. So then you use the dimensions from the step 3. You write it back into the equation that we formed, and then you solve it. You'll get C, you get B, you get A and D. So you get equations, and then substituting the value of A, B, C, D in step 2, and then you have to substitute the linear equations we got into the main equation, and then we solve it. We'll get the answer. F equals to d power d square v square rho phi mu rho vd. That will be the final answer. Thank you.